What if on July 3rd, astronomers suddenly confirm something that changes everything we know about our cosmic neighborhood? A brand new galaxy discovered surprisingly close to the Milky Way. At first, it would sound impossible. For decades, humans have believed they understand the structure of the universe fairly well. We know our Milky Way is part of a group of galaxies called the Local Group, and we also know space is vast, with billions of galaxies scattered across unimaginable distances. Yet the idea of a completely new galaxy appearing close to us would shake even the strongest scientific confidence. The announcement would likely begin quietly, an unusual signal picked up by a deep space telescope, something too large, too structured, and too distant to be a star cluster or a nebula. At first, scientists might assume it is a data error. Instruments sometimes misread cosmic dust clouds or overlapping light from distant objects. But as more telescopes confirm the same observation, curiosity would turn into urgency. If a new galaxy were truly found near the Milky Way, it would rewrite textbooks instantly. Astronomers would rush to study its shape, size, and motion. Is it spiral like our galaxy, or irregular and chaotic? Does it contain billions of stars? Or is it a small dwarf galaxy hidden behind cosmic dust for millions of years? These questions would become the center of global scientific attention within hours. One of the most fascinating possibilities is that the galaxy was never new. It was simply hidden. Space is not empty. It is filled with dust, gas, and dark matter that can block light. A galaxy could exist in plain sight, yet remain invisible because its light never reached us clearly. Advanced telescopes using infrared or radio waves might finally reveal what optical telescopes could not see before. Another possibility is even more exciting: gravitational interaction. If this galaxy is close enough to the Milky Way, it might already be influencing. A sudden discovery of a new galaxy near the Milky Way would shock the scientific world and challenge existing cosmic understanding. A sudden discovery of a new galaxy near the Milky Way would immediately become one of the most extraordinary moments in the history of astronomy, because it would challenge one of the most deeply established ideas in modern science, that we already have a fairly complete map of our local cosmic neighborhood. For decades, scientists have used increasingly powerful telescopes, optical, radio, infrared, and space-based observatories, to chart galaxies in the Local Group and beyond. So if a completely new galaxy were suddenly detected nearby, it would not just be surprising. It would force researchers to question how such a massive structure could have remained hidden for so long in a universe we have been observing so carefully. At first, the discovery would likely be met with skepticism. In science, extraordinary claims require extraordinary evidence, and a nearby galaxy would certainly qualify as extraordinary. Researchers would carefully examine the initial data, looking for signs of error, interference, or misinterpretation. Instruments can sometimes produce misleading signals due to cosmic dust, overlapping light sources, or gravitational lensing effects that distort distant objects. So before anyone accepts the idea of a new galaxy, multiple independent observations would be required from different observatories around the world, and even from space-based telescopes. If the finding holds up under scrutiny, the scientific community would enter a phase of intense investigation. The central question would be how such a galaxy remained undetected until now. One possibility is that it was hidden behind dense regions of cosmic dust within or near the plane of the Milky Way. The galaxy could have been there all along, its light absorbed or scattered so heavily that traditional optical telescopes simply could not see it. Only with newer tech. Once the existence of a newly discovered galaxy near the Milky Way is confirmed, the scientific world would shift into an intense phase of analysis, collaboration, and rapid technological deployment. What initially began as a questionable signal or an unusual pattern in telescope data would now become one of the most important astronomical targets ever identified. Observatories across the globe, along with space-based instruments, will be directed toward the same region of the sky to collect as much data as possible. Every wavelength of light, gamma rays, X-rays, ultraviolet visible light, infrared, and radio waves will be used to construct a complete profile of this mysterious galaxy. One of the first priorities would be determining its exact distance. In astronomy, distance is not just a number. It is the key to understanding scale, history, and behavior. If the galaxy is relatively close, it might have interacted with the Milky Way in the past, or it could be gravitationally bound to it. Scientists would use methods such as redshift measurements, standard candles like Cepheid variables, and other distance indicators to calculate how far away it truly is. Even a small error in these measurements could dramatically change interpretations, so the process would be repeated and verified many times. At the same time, researchers would focus on the galaxy's structure. If it is a spiral galaxy, they would examine the shape and symmetry of its arms, looking for signs of rotation and star formation activity. If it is irregular, they would investigate whether it was disrupted by gravitational interactions, possibly with another galaxy or even with dark matter structures. The distribution of stars within it would provide clues about its age, formation history, and stability. Some regions might be densely packed with young, hot stars, while others could contain older, cooler stellar populations that hint at earlier cosmic eras. Scientists would urgently study the galaxy's structure, distance, and movement to understand whether it is spiral, irregular, or hidden by cosmic dust. Once the newly discovered galaxy near the Milky Way becomes a confirmed astronomical object, one of the most important scientific efforts would be to understand its origin story. Every galaxy carries within it a history written in its stars, gas clouds, and structure, and this one would be no different. Astronomers would begin by analyzing the ages of its stellar populations. If it contains a mix of very old and relatively young stars, that would suggest a long and complex evolutionary path. If it is dominated by older stars, it might be a remnant of an ancient structure that formed early in the universe's history and has remained relatively unchanged. On the other hand, a galaxy rich in young, hot stars would indicate active star formation, possibly triggered by interactions with nearby galaxies or internal gravitational collapse. Researchers would also focus on chemical composition, often referred to as metallicity in astronomy. The abundance of heavier elements in stars reveals how many generations of stars have lived and died within a galaxy. A higher metallicity usually suggests a more evolved system with multiple cycles of star formation and supernova explosions. If this newly found galaxy shows unusual chemical patterns compared to known galaxies in the local group, it could challenge existing models of how galaxies enrich themselves over time. This might even suggest that the galaxy formed in a different environment or experienced unique cosmic conditions. Another major focus would be the galaxy's motion through space. By studying redshift and blueshift data, scientists would determine whether it is moving toward or away from the Milky Way. If it is approaching, long-term predictions would be made about gravitational interactions in the distant future. Even if a direct collision is not imminent, the finding could reshape theories about galactic motion, gravity, and possible interactions between the Milky Way and nearby galaxies. Once the discovery of a new galaxy near the Milky Way is fully confirmed and its basic properties are understood, attention would gradually shift toward its deeper implications for cosmology and the long-term structure of the universe. Scientists would begin asking questions that go beyond description and enter the realm of interpretation. What does this galaxy mean for our understanding of cosmic evolution, and how does it fit into the broader architecture of space? One of the most important areas of focus would be galaxy formation theories. Current models suggest that galaxies form through gradual accumulation of gas, dark matter collapse, and repeated mergers over billions of years. If this newly discovered galaxy appears unusually well-preserved or structurally unique despite being close to the Milky Way, it could challenge these long-standing theories. For example, if it shows little sign of past collisions or disturbances, scientists would need to explain how it avoided gravitational interactions in a region of space that is already considered densely populated by cosmic standards. This could suggest that our understanding of galactic environments is incomplete, especially in regions between large galaxies. Another major implication would involve the mapping of the local group itself. The local group is currently believed to contain a limited number of major galaxies, including the Milky Way and Andromeda, along with numerous dwarf galaxies. The addition of a previously unknown galaxy would force astronomers to redraw parts of this map, potentially redefining boundaries and gravitational relationships within a group. If this galaxy is gravitationally bound to either the Milky Way or Andromeda, it could play a role in future orbital dynamics on a massive scale. Over millions of years, even small galaxies can influence star